everyone, and welcome to Geometry Section 2.2, Angle Bisectors. In our last section on segment bisectors, we defined the word bisect, and we talked about what that meant for a segment. And if you remember, a segment bisector is just a line, ray, or segment that divides a segment into two congruent parts. So today we're going to be using that word bisect again, but this time with angles. So most of you can probably figure out what an angle bisector is just from knowing what the word bisect means. An angle bisector is a ray that divides an angle into two congruent angles. So below here, we'll call this angle ABC, with B as its vertex. And then I'm going to draw in ray BD here, and that will be the angle bisector for this angle. And if I know that ray BD bisects this angle, then I know that angles ABD and angles DBC are congruent. In symbols, this is what this would look like. I have ray BD, and I know that it bisects angle ABC, and that means that angle ABD is congruent to angle DBC. Now let's try a couple problems that will have us using angle bisectors. In this first problem, we're asked to find the measure of angle MNQ and the measure of angle PNQ if ray NQ bisects angle MNP and the measure of angle MNP is 74 degrees. Just looking at that, this problem seems pretty confusing. One great strategy for solving geometry problems like this is to draw a picture. So we're going to start by sketching the big angle that they talk about in this problem, angle MNP. So N is my vertex, and then it also says that I have ray NQ bisecting that angle. So in about the middle of this angle, I need to sketch ray NQ. And now that we've got ray NQ and we know that it's an angle bisector, we know that angles MNQ and angles Q and P are congruent. So we can mark that in our picture. And then they tell us that the entire angle is 74 degrees. Pay attention to how I drew those arcs in there. Those two smaller arcs are marking that the two smaller angles are congruent, while the larger arc that goes across both of them tells the measure of the entire angle. You'll see problems like this in your textbook, in your practice problems, and also on your tests. So now we're going to use what we know about geometry to write an algebra problem that we can solve to find the answer to this problem. So in this problem, I know that the measure of angle MNQ is going to equal the measure of the big angle, angle MNP, divided by 2, since it's just half of that larger angle. So if I just take 74 divided by 2, I'll get the measure of the larger angle, 37 degrees. And then from there, I know that my two smaller angles are congruent. So if the measure of angle MNQ is 37 degrees, then the measure of angle PNQ also has to be 37. Now let's look at another problem like this. In this problem, we're asked to find the measure of angle ABD if angle ABC is bisected by ray BD and the measure of angle ABC is 40 degrees. So again, let's start by drawing a picture so we can see what the problem is asking and telling us a little better. So I'm going to start by drawing angle ABC. And then it has this bisector, ray BD. So right down the middle, I'll draw that ray. So once I have my bisector in there, I know that angle ABD and angle DBC are congruent, so I'll mark that. And then I'm told in the problem that the measure of the whole angle, angle ABC, is 40 degrees. Now there are a couple of different ways we can look at this, and I showed you this first one in the last problem, but I want to show you another way you can think about it too. So the measure of angle ABD is going to be the measure of the larger angle divided by 2. So I can just write 40 over 2 and I get 20 degrees for the measure of angle ABD. Another way for you to think about it, and if it's easier for you algebraically to look at it like this, then that's fine. The measure of angle ABD is equal to half of that entire angle. So I can just take half of 40, or 1/2 times 40, and get 20 degrees that way too. Either way you work it out is fine, but different notations sometimes help us see the problem a little more clearly. Let's keep going with these problems, but this time we'll try something a little bit different. So in this problem, we're asked to find the measure of angle ABC if angle ABC is bisected by ray BD and the measure of angle ABD is 80 degrees. So I'll sketch my angle again. So here's angle ABC, B as its vertex, and then I'm going to sketch in that angle bisector, ray BD, and now I know that angles ABD and DBC are congruent. And I'm also told in my problem this time that the measure of angle ABD, that smaller angle, is 80 degrees. Then I know because these angles are congruent, angle DBC also has to be 80 degrees. And in this problem, I'm looking for the measure of the larger angle, angle ABC. There are a couple of different ways we can look at this. First, we can use the angle addition postulate that we learned in the last chapter. And writing that out algebraically, it would look like this. The measure of angle ABC is equal to the measure of angle ABD plus the measure of angle DBC. I know that the measure of angle ABD is 80 degrees, and I know the same thing, measure of angle DBC is 80 degrees also. And then adding those two together, I'll get that the measure of angle ABC is 160 degrees. Another way to look at this is using the concept of angle bisectors. So I know that the measure of angle ABC has to be twice the measure of one of those smaller angles, or 2 times the measure of angle ABD. So if I just do 2 times 80, I'll get the same answer, 160 degrees. Let's look at one last example of angle bisectors. In this problem, we're asked to find the value of x if angle FGH is bisected by ray GL. Now they've conveniently drawn us a picture for this one already, which is pretty nice. So we can see that we've got angle FGH, and we can see its bisector angle GL. So we know from that angle FGL is congruent to angle LGH, so we'll still mark those on there. And then if two angles are congruent, that means they're equal. So I know that the measure of angle FGL has to equal the measure of angle LGH. In my problem, it shows that the measure of angle FGL is 45 degrees and that the measure of angle LGH is 6x minus 3. So if I set those two expressions equal to each other, I can build myself an algebra problem to solve to get the right answer for this. So to solve this algebra equation, I'm just going to start by adding 3 to both sides. So then I'll have 48 equals 6x. Dividing both sides by 6 will leave me with 8 for x. That's all for lesson 2.2. Remember, you can go back and rewatch any parts of the video if there was something that you didn't understand. And thank you for joining me, and happy hypothesizing.